Okay, example 1, finding R using formula 10-2. We're going to use formula 10-2 to find the linear correlation coefficient R for the Powerball jackpot amounts and numbers of tickets listed in the table. So if we come down here, this is formula 10-2. So R is going to equal the sum of the z-scores for the x times the z-scores for the y over n minus 1, where n is the sample size. So over here what we're going to do is we're going to create a table. First column represents x, which is the jackpot. The second column is y, which is the tickets. The third column is x bar, which is the mean of the x values. And S subscript x, which is the fourth column, is the standard deviation of the x values, and that's of the jackpot. And then we want to find the z-score for x, where we take the value of x, we subtract the mean of the x values, and divide it by the standard deviation of the x values. And then for the y's, we want to find the mean for the y values, which are the tickets, and then find the standard deviation of the y value or the tickets. Once we find that, then we're going to find the z-score for those y values, and that's going to equal y minus the mean of the y values over the standard deviation of the y's. So here, let's first take a look here. Here we put in our values for x, which represents the jackpot values. And then we have our second column, which represents the y values. Okay? So the first thing we want to do is we want to put this data into StatCrunch and find the mean and the standard deviation for the x values and the mean and the standard deviation for the y values. So we're going to come in here, we're going to open up StatCrunch, we're going to create a jackpot column, we're going to put that in as x, and then over here these are our tickets, and then we're going to make sure that that represents our y values. And so now what we're going to do is we're going to go to Stat, go to Summary Stats and select Columns. And then we're going to select both of these columns. And then we're going to select the value of the mean and the standard deviation for both of them. So let's go ahead and select Compute. Okay, so let me go ahead and copy this just to make sure that we can then use this on our sheet. So let's take a look below here. So for the mean for the x values, it's 214.88889. So we're going to put in our mean for 214.889 for every value there. And the standard deviation for the values of x is 70.506107. So we get 70.5061, and we just rounded that to 4 decimal places. So we rounded this to 4 decimal places, and we round that one to 4 decimal places. And then for the y mean values, it should be 26.5556. So round that to 4 decimal places, we get 26.5556. And then for the standard deviation for the y values, round to 4 decimal places, we're going to get 12.9626. So we get 12.9626. Okay, so now what we're going to do is we want to go ahead and then find the z-score for this. So to find the z-score, we're going to put the following. We take in a value of x, which is 334, and then we subtract the mean of 214.889, and then divide it by the standard deviation. And we get rounded to 4 decimal places, we get a z-score of 1.6894. Okay, if we do the same thing, we take the value of x, which is 127, and then subtract the mean of those values of the x values, and then divide it by the standard deviation. And now we get negative 1.2465 for the z-score. Okay, then we take the value of 300 and then subtract the standard deviation again, and then divide it by the, subtract the mean and then divide it by the standard deviation. We get 1.2071. As we continue, we take 227, subtract the mean over the standard deviation. We get 0.1718. And then we take 202, subtract the mean of the x values and divide it by the standard deviation. We get negative 0.1828. And then we take 180, subtract the mean, and then divide it by the standard deviation to get negative 0.4948. And then we take, again, 164, subtract the mean, divide it by the standard deviation, and get negative 0.7218. And then we take 145, subtract the mean, and divide it by the standard deviation, and get negative 0.9912. And then 255 minus the mean, divided by the standard deviation to give us 0.5689. Okay, so now we're going to take a look at the y's. So for here, we're going to take the y value. So the y value is going to be 54. Okay, and then we're going to subtract the mean of the y values, and then we're going to divide it by the standard deviation of the y values. And then that gives us 2.1172. Let's do that for a few more there. Again, we're going to take the y value of 16, and then we're going to subtract the mean of the y values, and then divide it by the standard deviation. And again, we get negative 0.8143. Let's do one more there. Again, we're going to take the y value of 41 and then subtract the mean of the y values, which is 26.5556, and then divide that by the standard deviation of the y values to get 1.1143. So again, we're taking the value of y, 27, minus the mean of the y values divided by the standard deviation of the y values to get 0.0343. We take 23, which is the y values, subtract the mean of the y values divided by the standard deviation of the y values to get negative 0.2743. Take the y value of 18, subtract the mean of the y values divided by the standard deviation to get negative 0.660. We have another y value of 18, so we get the same value of negative 0.660. And then we take another y value of 16 minus the mean of this y values divided by the standard deviation of the y values to get negative 0.8143. And then last, we take the y value of 26, subtract the mean of the y values divided by the standard deviation of the y values, and that gives us negative 0.0429. So now what we want to do is we want to take the z-score of the x values and multiply it by the z value of y. So what we're going to do is the following. If we come back up here, okay, and let's take a look. We have 1.6894 for the z, and then for the y it's 2.1172. So when we multiply them together, we get 3.57680. Okay, take a look at the next one. If we take the z-score of the y value and then divide it by the the x value, and then multiply it by the z-score of the y value, then we get 1.10502. If we take the z-score of the x value here, which is 1.2071, multiply it by the z-score of the y value here of 1.1143, and we get 1.34507. Next, 0.1718 times 0.0343 gives us 0.00589. Negative 0.1828. Multiply that by negative 0.2743 to get us 0.05014. Negative 0.4948. Multiply that by negative 0.6600, gives us 0.32657. And negative 0.7218 times negative 0.6600 gives us 0.47639. Negative 0.9912. Multiply that by negative 0.8143, and that's going to give us 0.80713, and the last one 0.5689. Multiply that by negative 0.0429. It gives us negative 0.02441. Now we want to add up everything in this entire column. So that is the sum. So when we add up this entire column, we get 7.57862. So now what we want to do is we're going to use the sum that we found here in this column of 7.57862, and then the value of r is then calculated. So we're going to use that value as our numerator, and then we're going to divide it by the sample size minus 1. So there is our value. We have 7.57862. Divide that by the sample size of 9 minus 1, and then we get 0.947. So let's go ahead and do that just to verify that. We take 7.57862, divide that by 9 minus 1, which is 8, and then rounding that to 3 decimal places, we get 0.947. So again, this gives us our linear correlation coefficient R, and that tells us that we have a positive linear correlation.